This podcast is brought to you by Enlightening Learners Academic Coaching and Tutoring Service. In this presentation, we're going to learn how to graph quadratic equations, and that is to graph parabolas accurately. The questions that you'll need to be answer. So a quadratic function is a function of the form fx equals ax squared plus bx plus c, and a cannot be equal to 0. So a graph of a parabola is U-shaped. It will either open down or it'll open up. And once again it's a graph that runs forever. Now these graphs, like linear graphs, can be graphed on a coordinate system. The reason why we identify A, B, and C is because they'll actually help you when you start graphing these. So we're going to work through that process now. Okay, the y-intercept is always going to be the letter C. So whatever this letter is, it's going to tell us where it crosses the y-line. The line of symmetry is a vertical line, so it's a line that runs up and down, and it splits the graph into two sides. And finally, the vertex is either the highest point or the lowest point on the parabola. So let's kind of go through this. We have an equation, y equals 3x squared minus 5x plus 2. So in this equation, the letter C is right here. And that's important because it tells us where it crosses the y-line. So in this case, the y-intercept is a positive 2. C is a positive 2, so the y-intercept is a positive 2. So if we're going to identify the point, it would look like 0, 2. I apologize, I don't have my board with me, so I'm working on a regular keyboard and mouse. So it's going to look a little sloppy. In this equation, A is always in front of my x squared, and so in this equation, A is positive 3. And finally, B is always in front of the x, and in this case, B is a negative 5. So the equation of line of symmetry, so that's going to be a dotted line that runs between equidistant to both sides of the parabola. So our equation is negative B over 2a. So we plug in our values for negative b. So it's going to be a minus a negative 5 over 2 divided by 2 times whatever my a is. In this case, it's 2 times 3. So minus a negative 5 becomes a positive 5. And 2 times 3 is 6. Now that might seem odd, and we'll graph this in just a minute. So we've got our y-intercept at positive 2. I'm going to go ahead and plot a point right there. So let me make this a different color. My y-intercept is a positive 2. Remember that point was 0, 2. My line of symmetry is 5, 6. So it's not quite positive 1. You get the general idea. My y-intercept is 0, 2. And line of symmetry is a positive 5, 6. Now I know that this graph is going to open up, and that's because A is a positive. So it's going to look something like this. And it's going to cross the line of symmetry here. And so it's going to look something like this. So to find the vertex, that's going to be the lowest point because it's a smiley face. I plug in 5, 6 into this equation. So 3 times 5, 6 square that minus 5 times 5, 6 plus 2. So through the magic of technology, I've kind of worked this problem out. I plugged in my line of symmetry into X in both cases and substituted that. And when I did that, 5, 6 squared is 25 over 36. And when I multiply that by 3, the 3 can cancel out the 36. 3 goes into 36 12 times, so I get 25 over 12 minus 5 times 5, 6 is 25, 6, and then plus 2. Well, I calculated that my common denominator is 12. 6 can go into 12, so I multiplied both of these by 2 to get 50. And so what you see is 25 minus 50 over my new common denominator, which is 12, plus 2. 25 minus 50 simplifies to negative 25 over 12. Now 12 goes into 25 twice, so it's actually 2 and 1/12 plus 2. So that, remember, this is a negative, so negative 2 and 1/12 plus 2 gets me a negative 1/12. So my line of symmetry, excuse me, my vertex, is going to be down here, very low, right about there. Draw this a different color. And this 1/12. I know that the point it crosses the y-intercept is at positive 2 because that's what my C is. Remember, that's where this is. And the line of symmetry, it divides this graph up into a left side and a right side. And so I know that when this graph is going to come up here, and it's going to be the same distance from this point to that point. And so this distance is 5, 6. So I know that it's going to be 5, 6 from here to there. So I'm just kind of guesstimating. And the next point is going to be there. So my graph looks something like this. And it continues up. Again, I apologize for the lines not being better, but I don't have access to my pen today or my tablet. So the graph is going to look something like that. Now, I know that my graph in this case is smiling. Notice that it's opening up because this A is positive. So in the case A is positive, if the A were negative, it would be frowning, or it opens downward. So let's go ahead and go through this. I know that this graph is going to look like it's frowning because the a is negative. I know that this graph is going to be a smiling face because the a is positive. This a is positive. And finally, this a is negative, so it's going to open down. Now we talked about finding the vertex already. Once you find the line of symmetry, you're going to plug that value into your equation and solve. So here are your steps. First thing you want to do is graph the y-intercept. That'll be identified from your point C. Then you're going to figure out the line of symmetry. Remember, the line of symmetry is the opposite of whatever b is divided by 2 times a. And that value is actually x. So you're going to find x, and you're going to plug, once you get this value, you're going to plug it into these equations to graph the vertex, to find either the highest or the lowest. So if your graph is a negative graph, meaning it's frowning, it's actually going to have a maximum value, which would be right there. If your graph is smiling, you're going to have a minimum graph, or the lowest point on the graph, which would be right there. Okay, go ahead and work these problems out. My y-intercept is a positive 4. It's going to be right there. Negative b over 2a. My b is already negative, so a minus a negative is going to be a positive. So the line of symmetry is going to be a positive 8 over 2 times whatever my a is. In this case, my a is negative 3, so 2 times a negative 3 would be a negative 6. That can be reduced because both of these numbers can be divided by a 2, so it becomes a 4 thirds. Remember, it's negative. So negative 4 thirds. So technically that's going to be a negative 1 and 1/3. So negative 1 goes to the left 1 unit and then a third more over, and we draw our line of symmetry going down. So I know that this is 1 1/3 units from my line of symmetry, so I can move this over another 1 1/3 and it's going to have another point there. So I already know what the general shape is going to look like. It's going to be a frowny face. So the vertex is going to be somewhere up here. We don't know yet because we've got to figure that point out by plugging this value into this equation. But I know that my shape is going to look like this. It's going to go from that point going down, and it's going to eventually, it will cross my x line. So I can already get a general sense of what that graph is going to look like. And when we do the math, essentially that's what the graph looks like. We plugged in our negative 4 thirds into the equation, we worked through it, and my vertex is at negative 4 thirds and all the way up here at positive 20. And I get 20 when I plug in that value in there. So go ahead and copy that work down.